When picking your U and your dv for integration by parts, a handy mnemonic to remember is LIATE, which stands for logs, inverses, algebraic expressions, trig expressions, and exponentials. And so the idea here is you let U equal the first thing on this list that shows up in what we're trying to integrate. So let's see how that works. So in our first example here, we have x to the fifth ln x. So x to the fifth is algebraic in nature, whereas ln x is logarithmic nature. And so for u, we're going to pick the logarithmic expression. We're going to pick the natural log. And our dv will be everything else, will be the x to the fifth dx. And then we can continue on from there, integrating. So let's go ahead and run through this one real quick. So du will be 1 over x dx. V will be 1/6 x to the 6th. And so we'll get u times v minus integral of v du. And in this case, one of these x's will cancel with one of those, leaving us with something we can integrate. So we have our original 1/6, integrating x to the fifth, we get another 1/6, and there's our antiderivative. Okay, and so there's the first example. Let's take a look at the next one. So here, we have sine inverse of x, which is an inverse expression, and then dx, which is our algebraic expression here. So in this case, we would end up letting u equal sine inverse, and dv would equal dx. So then du would be 1 over square root of 1 minus x squared dx, and v will be just x. So then in our integral, we have u times v minus the integral of v times du. And then it turns out that this integral we can do using basic substitution. So if we let u equal 1 minus x squared du negative 2x dx, then this will become negative x over root u times du over negative 2x. The x's cancel, so we end up with positive 1/2 integral of 1 over root u. Remember, 1 over root u is u to the negative 1/2, so the integral of that will be u to the positive 1/2 divided by 1/2. So we'll have positive 1/2 times 2 root u. Back substituting, that'd be a square root of 1 minus x squared. So putting that back together here, we'd have x sine inverse of x plus this root 1 minus x squared plus c as our integral of sine inverse. All right, so now let's take our next look at our next example here. So here we have e to the x, which is exponential, and sine, which is trig. Since trig shows up first on the list, we'll let u equal sine x, and dv equal e to the x dx. And I'm not going to show that one the rest of the way through in this video. For the next one, we have x, and x is algebraic. E to the x, which is exponential. Since algebraic stuff shows up first in the list, here we'll let u equal x, and dv equal the e to the x dx. In the last example here, we have x squared, which is algebraic, and cosine x, which is trig. So we'll let u equal x squared, and dv equal cosine x dx. All right, so that's how we can use LIATE to help us identify our u and our dv in integration by parts.